Yeah, so we got a little PLC in the house now. So we're gonna play around with this bad boy right here, if you guys can see that. We haven't even got it wired in yet. See what I'm saying? So we're gonna do the wiring live. This is kind of my little this is my trainer, boys. You know what I mean? You don't have to go out there and you don't have to buy a big fancy electrical trainer to learn this stuff. This is a broken piece of plexiglass. You know what I'm saying? If you could get your hands on a piece of plexiglass and a drill, man, you got it. You don't need the big fancy trainers that they sell online, which you can buy one. It's nice because it's already all put together for you, but you could do it yourself. So today we got this little PLC that we're gonna get programmed in, and then I got a little breaker, I got a relay, I got some junction blocks, and we're gonna get it. What's up, fellas? How you guys doing out there? Low cool, yeah, salt water. So let's do this. So first thing I want to do, I like using these little Wago terminal blocks, because I can mount all these little Wago terminal blocks all in one. So today, in order to get my power, I am going to snap off this little Wago terminal block. And I got a 3, a 5, and a 2. So let me put let me make this one my hot and neutral. Oh, you know what? Let me make this one my hot, because we're gonna need a lot of hots. Let me see. So we got one motor. We got one motor getting wired. We got one indicator light getting wired, and one relay getting wired. So that's gonna take a hot. That's gonna take a hot. That's gonna take a hot. The PLC is gonna take a hot. So we're gonna need 2 blocks of hot, 2 blocks of solid 120 in order to keep the 120 volt power coming in. And then we'll do 1 terminal block full of neutral. We'll do the neutral, you know what I'm saying? And then that'll give us enough power to play with all our little devices. But yeah, so I have other terminal blocks, but let's use these for today. This will do. So let me take off another one and another one. Let me get that guy off of there. Okay, so here we go. So I'm gonna pop this out. I'm gonna use 2 5s, 2 5-pin. So these ones are 5, and these are cool because look it. If you were to actually use these in a permanent control panel, they're numbered. So you could label this terminal block 1, terminal block 2. So this will be like TB1 number 1. Just like you label a breaker panel, switch panel. Terminal block 1, number 1. Terminal block 1, number 2. Terminal block 1, number 11. So you guys can use these just like a OG terminal block and wire in some nice little control panels for yourself if you were so eager to do that. You know what I mean? That's what I do. I like to use these. They're cheap and they're reusable. So you don't have to get rid of them after you finish with it. You just save it up. They say the Wagos are expensive. They're not too bad because once you buy these, you get to keep them forever. It's not like a wire nut. I'd probably rather buy these than buy a bunch of wire nuts if it's going to be something for your house or your home little, your little tabletop test lab, kind of like this get down right here. You know what I mean? That's probably going to be the way to do it. So this one, we're going to make the hot, the absolute hot. We're going to plug that bad boy into there, right? And then we're going to make, we'll get 2 hot rails. We'll get 2 hot pots. So let me go ahead and grab me another red. You see this wire right here? You see this wire? This wire comes from ballast. Whenever I wire lighting, I save the ballast. I save these wiring from the ballast. It's nice because when you guys take this wire off, it's already coated with solder. See that? It's all solder coated, so you don't get those frayed wiring. Yeah, it's nice wire to save. If you guys do lighting out there, I always save these little wiring harnesses. You know what I mean? Just a little tip. Save you some cash. I have a spool of like 16 gauge control wire, but why would I use that when I could just use this? You know what I'm saying? Boom. It's my setup right there, son. That's the setup right there, son. That's it. That'll get you through most of your day. So now let me set a double Wago, a two pin Wago for my neutral wire. So let's go ahead and get my neutral wire wired in. For my neutral, I'm gonna keep it OG. I'm gonna keep it color coded, and I'm gonna bang out the white wire for my neutral. Just because I don't want no confusion when I'm wiring. Not that there will be, I you know what I mean? But we'll just do it like that. Here we go. So there's my neutral. There is my neutral. Ah, there it is. So we got from my inverter, we got my power cord, right? We got my source voltage, my power whip, my whip inlet coming in, and from here is the end of my whip. I got a red and a white, which typically indicate 120 volt. For all you guys out there that are super detail oriented, even though this is the kitchen table, we could do whatever we want right here. We could do whatever we want. There are no rules. There are no rules on the kitchen table. You know what I'm saying? So this is the IDEC F1 or FL1D PLC. What up, son? Martin, what's happening? You back in the house, huh? You ready for another round, Martin? You ready for another round? Let's go, dog. Let's go. Let's get this. Martin in the house. That's right, boy. That's right. Let me change this sticker. Right? I'm gonna change this little sticker so that I'm gonna change it. I got a little call coming in. I'm gonna change this little sticker right here, son. Right there. Blah. And it's the FL1D. FL1D. Hold up. So the L1D. So it's gonna be the L1D PLC testing. Bam, there it is, boys. There it is. All right, so that's it. I keep getting a call. Is that a Eaton E4 Easy Relay? Hey, it's funny, DJ, because this is not a Eaton. Look at the tag. Look at the sticker on the screen. Look at the sticker on the. I'm getting a call. I'm getting messages. So sorry about that. Okay, so look at the sticker on the screen. This is an IDEC, DJ. This is an IDEC smart relay. But it's funny because Eaton, there it is. See that? No, that's an Eaton breaker, but that's an IDEC smart relay. 100 right here, 20 volts, 100 to 240 AC or DC. Yeah. No. Hey, here's the thing, DJ. They're all the same. Everybody buys the same damn little relay, but they put their name on it. So if you know how to do one, you know how to do them all. Siemens, Eaton, IDEC, everybody bangs out the same box. It's just a 4 output, 8 input relay. That's it. But I'm about to wire it, and I wasn't going to show you guys this part, But I'm like, hey, what the heck? I'm gonna let you guys watch me set it up so you guys could clown me when I make a mistake. You know what I'm saying? I'm gonna let you get yours. Go ahead then. Go ahead then, get yours. You know what I'm saying? You guys could clown me. I don't care. That Eden E4 is damn. It is identical, DJ. It's the same thing. What up, Scoop? Just the tip. Oh, savage. What's up, Just? Yeah, we right here, brother. Yeah, so anyways, I'm gonna let you guys watch me wire it live. So if I smoke it, hey, you know what? You guys could clown. It's okay. I'm not even tripping, bro. I'm not even tripping. You know what I'm saying? Not even mad at you. But guess what? I'm not gonna do that. I'm not gonna give you guys fuel for the fire, boys. I already know how you guys are. I already know how you guys are. You try to eat me alive, boys. You guys trying to eat me alive, boys. I already know it. I already know it. I already know. I already know. You guys ain't that forgiving, man. I already know. All right, so we got our neutral and we got our hot conductor. And today we're using the Wago terminal blocks. So I'm gonna make this Wago all hots. Bam. Bam. So this is gonna be all hots on this Wago. So let me go ahead and snip and trim my little red wire right here. This is what I was looking for. Bam. It's sticky. It's sticky. You feel it sticky? This is OG. This is from the field, boys. This wire is straight from the field, just like you. And not the strawberry field, the electrical field, where we out there putting in work. That's where this came from. This came from me out there putting in work, and I brought it home with me. And I'm gonna go ahead and snip this bad boy, and I'm gonna make me a little jumper. I'm gonna make me a little jumpy jump. And my wife gets mad. My wife gets mad, and I'm sure you guys already know how the electricians do it. And I'm gonna show you exactly how we do it right here. Gone. You see that? It's gone. First it was here, now it's gone. You see the TikTok with the Amazon? Oh, is he? No, I haven't seen that. I'm gonna have to check that out, Scoop. Amazon electrician making $100 an hour, right? Yeah. All right. In typical electrician fashion, here we go. Typical electrician fashion, we got 10 gauge, we got 12 gauge, we got 14, and then we got 16 right there, right? That's all the numbers of gauges on there. Check this out. He got fired? I did not. Oh, gone. Where'd it go? Where'd it go? Yeah. The wife's gonna kill me. He got fired? What? How'd that happen? How'd that happen, Scoop? How do you get fired from Amazon? The Amazon electrician? Oh, was he like recording and stuff? Hold up, let me go see. Because I want to know about this. You got me interested. Amazon has no... Yeah, you can't do that. You can't do that. $100 an hour? Oh. For that much? Look it. Don't go do what I do, guys. Big Rick is allowed to do it. You know what I mean? I read my company policy and we cool. We are good to go, boys. You know what I mean? My boss, he knows. I get a lot of people out there. Oh, what? Talking about why am I filming at work? Because I can. Because I can. Plus, he was breaking like a bunch of safety rules. Okay. Yeah. I try not to do that, but no, everything that I do is on the board. You know what I mean? 1000%. No breaking, no safety rules. I did not hear about that, but I would like to see that. Amazon electrician, huh? Amazon electrician, you say? It was a holiday. We get holiday pay and time and a half. Nice. Big pay. Yeah, man. Hey, for $100 an hour? Shoo-wee. That's nice. All right, so let's get back Let's get back. Yeah, hey, it's okay. Hey, he should land on his feet. To be honest with you, Scoop, he should land on his feet. You know what I mean? Hey, here's the beauty of it. If you pack in those kind of skills, you're gonna land on your feet. You know what I mean? You, me, him, we'll land on our feet, and then you learn a little lesson like read your company policy before you start doing stuff, right? Straight up, boys. Straight up. Hey, but don't be shy, guys. Hey, you guys can go ahead and tap that screen. We get that like count up, boys. Get that like count up. Know what I'm saying? Know what I'm saying? I'm murder. Hey, you ever seen that guy on TikTok? I'm murders. I'm murders. I be tripping out on some of the people that are on TikTok, man. It's crazy. I'm murders. All right, so we got a hot rail. We jump it over, so I'm going to carry over all this hot wire into these two terminal blocks. I'm going to squish them. Booyah. And then we're going to use these to power the entire unit. So first of all, we don't want this guy here. We don't want that guy there. We want that guy at the bottom of our breaker. That's where we want him at. So we got our multi tool screwy. Let's go. Let's go. Let's get it. Okay. On motors. You know what? Let me flip this wire because I think this side, yeah, is a little bit longer. Put that side on there. On motors. All right. You know what? I got a better idea. I'm telling you, man. Sometimes these ideas come to me, man. Let me take... Damn, it's kind of a mess, boys. Sorry about that. Kind of a mess. Let me get rid of some of this wiring around here. All right, so we're gonna power up this. We're gonna power up our feed voltage, our main breaker with our feed power directly on motors. All right. See what I'm saying? You guys see what I'm saying? Can we do that? Yes, we can do that. On motors. There it is. Okay. Okay. So there is one. So now let's get this neutral side wired in, right? Which we're gonna need. Let's get this guy off the DIN rail. Ah! Come on, boys. Oh! There we go. We got it, fellas. No need for emergency. We got it. We'll take this guy off the DIN rail. Oh my God, hold up. Amazon electrician, I got fired. Oh man, that's crazy. That's a lot of bread, man. $100 an hour. Oh. How do you do that? So we're gonna use this guy as our neutral, right? Yeah. Bam. Use him as the neutral. And I will cut a little strip of neutral, right? Cut me a little jumpy. So I got the little jumper right there, boys. Let's see. So we're doing some Wagos. Yes, sir, Sawyer. We got the Wags in the house. 1,000 likes, boys. Hey, shout out to you, fellas. Thank you, brothers. All right, so typical electrician fashion. Now you see it, right? Now you see it, brat. So this is 10, 12, 14, 16. Now you see it? Now you don't. Where did it go? Where did it go? That's just like an electrician, boys. You know what I mean? Little scraps and cuts and snips everywhere, boys. Straight up. It ain't no different at the kitchen table. I'm just kidding. I'm gonna have to find that and pick that up, because if my wife sees those, she gonna lose it, boys. Yeah, fellas. Let's go, DJ. Let's go, chat. Keep that. Hey, good looking out for the hype. That's my hype guy right there, boys. That's my hype guy, DJ. Shout out to you, boy. All right, so here we go. Okay, so we're gonna jumper. We're gonna jumper this way go to this way go, just to give us plenty of terminal block space for what we're trying to do today. You know what I mean? Bam. All right, fellas. Okay. So, hold on. Wrong one. So I'm trying to keep them here. Let me show you guys what I did. You got the yellow unlocks right here, and I wired it backwards. So let me take that off. And let me unlock that one. Keep them both the same way. Okay. Yeah. So that when I run them back in their little housing, everything is the same way. Got it. Okay, cool. So we got neutral, and we got our hot. We're gonna have our hot right now. Bam. There it is. So we got neutral, our neutral conductor, which is a grounded conductor. It is called a grounded conductor. Guys get mad when you call it the wrong crap. You know what I mean? You come around some guys and they go be like, this is called your grounded conductor. This is called your ungrounded conductor. Ungrounded. At no point in the life of this wire is it grounded to anything. It would be a fatal error if this wire ends up touching ground. A fatal error that should trip your breaker if your setup is correct. You know what I'm saying? Always the old heads. Yeah, see how salty I sound, right? Hey, Scoop, you already know, dog. Hey, be tripping on some bull, right? You know what I'm saying, dog? Oh, man. Hey, I've been yelled at many a time. Oh no, grounded conductor. What's up, Shay? Snapping off like, yo, dude, what's up, man? Chill out, brother. Chill out. So, okay, so we're good. We are good. We got that. So now, let's go ahead and do our first check of the night, right? We're going to set, god dang it, boy, it's a mess. We're going to go to voltage. Hold on, let me reset this bad boy. Voltage. All right, so we have, it should auto-tune to what we need, right? So we're going to get him ready. And then I'm going to plug one of my probes into the end, because I want to make sure we're carrying over, right? I want to make sure we're carrying over from our grounded conductor over into our second terminal block. I want to make sure we're good like that. And then we'll take our ungrounded conductor, and I'm going to open up my last terminal right easy. Boop. Oh. All right, we got that. So now we're going to fire up. We're going to fire up the inverter, boys. And if it starts smoking, there ain't nothing to smoke yet. We're going to hit our play button. Hit that play button. And what do we got? Ooh. We got 5 volts. What you mean 5 volts, son? Oh. 5 volts because my breaker's off. You see that breaker? What's up, fellas? What up, fellas? That's good. Beautiful. Everything has an answer. Hit play. We hit the play button, and we got 117 angry electrons pumping in that wire. Pumping through those conductors. 117 angry electrons, boys. See that? See that? 117 angry electrons ready to do business. Man, you guys are flooding it with the hearts tonight. Good looking out. Sheesh. Much love for you, boys. Much love for you. Okay, so now that we got that, let's do everything in reverse order, right? These are my devices and I'm trying to keep them off. No voltage. Okay. Now we're going to go to this guy. Shut it off. And shut it off. Okay, cool. We're good, right? We're good? We're good? Nobody going to yell at me? Oh, he being up safe? These lives get uploaded somewhere. Yeah, right? All right. Nah, we heard that. Yeah. We're going to get 100,000. Hey, shout out to you, DJ. I'm not even tripping on the likes. You got to be up at 3 a.m. Son, I don't know where you at, but you better get some rest. Easy. All right. All right, here we go. Cool. So let's go ahead and undo that. Let's go ahead and undo that bad boy, right? Let's move my meter out of the way. Okay. And get these probes somewhere where they're out of my way. I know I'm just BSing tonight, kind of just having fun with you guys, but I should be able to wire this whole setup in like 5 to 15 minutes. Boop, 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 boom, hit that breaker, fully operational. You know what I mean? Which I could, but man, we just here talking smack, boys. You know what I mean? Ain't no rush. We off the clock. We having fun. We diving into our craft, and we trying to learn how to print that money, son. Let's print that money. This is how we gonna get to 100. This is how we gonna get to be $100 an hour Amazon guy. You know what I mean? Straight up, straight up. We gonna get to be $100 an hour Amazon guy. Because you know what? That dude that got fired from Amazon is probably hella smart. Hey, if you print the money, you let the smoke out a few times. Yes. And not get fired. Yes. You know why? Because it's not worth it. Here's the thing. Here's the thing. You have to respect the establishment. If they don't want you filming, it's for a reason. Because they have put in millions and millions of dollars into a process. I will. I'm gonna search it up, Scoop. They have put in they have put in millions of dollars in a process, right? And then you go putting their process on film, their competitors are watching. You know what I mean? You're basically giving away the secret for free. Proprietary. Yes. Do you guys understand that? You have to understand that. You know what I mean? So if I was doing that on the job and their policy was absolutely no filming, and they pulled me into HR and they're like, yo, bro, you know what? We've been noticing that this and that. And they're like, so we got to let you go. Like, I'm not even going to be mad at them, bro. Like, yeah, straight up. Not even going to be mad at them because I get it. If I was to start a company and you guys were to start a company, you're not going to want your workers selling out your secrets, so to speak. You know what I mean? So I get it. I'm not mad at them for firing him, and I'm not mad at him for trying to put that information out there. It's just that relationship, it just didn't work. You know what I mean? So, yeah, that sucks, man. $100 an hour. Oh, that's juicy. That's gravy, boys. That's gravy on Thanksgiving. That's gravy on Thanksgiving. Straight up. Okay. We have wired in. I'm going to tell you guys the secret sauce right now. How far I've gotten on this PLC. We have wired in two inputs to one output, okay? Not wired in, I'm sorry. I have programmed in two inputs to one output. Do you guys know what that means? Do you guys know what that means or why you would do two inputs to one output? I'm just saying, let me throw up another sticker because you guys are smart out there. I know you guys are because you guys be talking mad smack. Why would we wire two inputs to one output? Check it out, fellas. So we got another sticker. Oh, dumb. Hold up, guys. I'm getting this going. Hold on. I'm new at this. Two input, two. It don't even let you put that many to a sticker, man. Oh, that stinks. Anyways, let me go back with the IDEC. FL 1D PLC wiring, whatever. Bam, let's go. We're gonna stick with that, boys. Reset and start or a jug. Gus, okay. So I wired it so I could have one input on a maintain selector switch, and the other one, I'm gonna wire the other input to a capacitive sensor. So let's do it. Enough talking, let's do it. Hey, you guys get me going, man. Hey, if I had to work around you, nothing would get done. I'd be talking and like nothing would get done. You guys asking all the good questions, man. All right, so where we at? We've gotten as far as wiring our input source voltage breaker, our main breaker, right? Our main breaker. That's how far we got. And we've wired our main breaker, get all the tools over here, bam, put everything else over there, get all the distractions out of the way, and let's hit this, boys, let's hit this. So we have wired our main breaker to our ungrounded conductor and grounded conductor. So let's go. So now, what else is going to need power? Our PLC is going to need power. So let's get our first and our main device wired in for power. Let's go. Let's go. Okay. So if we want to do that, let's get a white wire. Right. Here we go. We got a little whitey, a little mighty whitey. What? A little mighty whitey. Okay, we got that. You know what? Let me use a bigger mighty whitey. Jeez, do I have some bigger mighty whiteys? Here we go again. 10, 12, 14, 16. Right there. Right there. Let's get 10, 12, 14, 16. All right. So let's get this guy wired in. Bam. So we're going to put the first one, little mini screwdriver. We're going to hit that first terminal, which is our neutral. Right? Okay. Now we're going to hit that second one right now. And I want to use another red. Let's use a red. And we go hit the red. the same way we hit the white, and we go strike it up right up in there, and the way it goes. Oh, thank you, sir. Thank you. Thank you, sir. So we got that into our L1, and one of them here at the top, one of them is labeled L1, and one of them is labeled N for neutral, right? All right, there it is. Check it out. So we got power. So if we move that, okay. So if we hit the inverter, and then we hit that. Oh, hold up. We should juice up. We should juice up. There it is, boys. The little hourglass came on, and we getting ready to go here. 24,000 fellas. Good looking out, man. You guys are killing it on the likes, boys. There's only 20 Mad Lad Savages up in here right now. All right, so look it. We opened up. Make sure I'm not touching nothing stupid. All right. So we opened up. And you guys could probably see that we are in a, can you guys see that? We are in a program menu. We are in the program menu. So I'm going to escape. But you notice that we are in stop. We are not running. We are not in a run condition. So we are in a stop condition, probably for programming. You know what I'm saying? Yup, that's him. All right, so let's turn it off. And let's move forward. Let's go to the next step, right? One by one device at a time. That's it, fellas. That is it. One device at a time. Nothing special. Let me turn off the power to my inverter, right? And we're going to move along with this. Who sent the rose? Randy? Hold up. You sent the rose, Randy? Oh, my guy. Hey, hold up. Wait a minute. Let me flip this screen, boys. Boys. Who sent that? Who sent that? Randy? That was you? That was you, Mom? Salud. Good looking now, son. You know what I mean? That's what makes it all worth it, boys. That's what makes it all worth it. Getting on camera, acting like a fool, doing this, doing that. Yeah, good looking out, Randy. Thank you, brother. You know what I'm saying? It takes a lot to get on camera. I don't know if you guys know that. It takes a lot to get on camera. It's not for everybody. I'll tell you that much right now. Getting on camera is not for everybody. If you want to get on camera, you better be ready for it. For absolutely no reason on earth, you better be ready for it. Because they're going to hit you with everything under the sun for absolutely no reason at all. So if you ain't got that thick skin, oof. You're going to be crying at night, boys. You're going to be crying at night. You know what I mean? It helps when you know what you're talking about. Well, yes, absolutely. That better be the first thing, right, Jay? Hey, you get on camera and you start trying to teach people about something that you don't know. Oh, my God. They going to eat you alive. You are on the menu. Okay. All right, so back to the wiring. So we now have our PLC powered up. So tonight, all we want to do tonight is try to start this little fan motor. This little fan motor. You guys see it? See it? A little 115 volt fan motor. Hey, who's that? Who that? Him? Hey, don't worry about it, brother. Hey, you ain't got to thank me, my guy. You ain't not got to thank me. I like doing it. You know what I mean? I'm learning the craft. So, okay. So this is a little 115 9-watt fan motor. And look what it says. It says CWLE, clockwise. I'm imagining it's gonna turn that way, clockwise, right? So I'm imagining it's gonna turn that way. But we're gonna see if we could get this guy started up tonight. Right? 1550 RPM, not even 1 amp. Okay? So we're trying to get this little fan motor started up tonight. But at the same time, what I want to do is, when that fan motor's running, I want that indicator light on. I want the indicator light to be on when that fan motor is running. You think we could do it? Do you guys think we can do it? Do you think we can do it? That's what we're doing tonight. Can we run a fan motor and have an indicator light tell us it's on? That is it. That is a 1000% basic function. You know what I mean? Bandit, good looking out. Yes, the answer is easy. Yes, we can do it. But we're going to show you guys how to do it. For those of you guys who have not done it, I want to show you guys how easy it is. It's not rocket science. We are not Elon Musk. You know what I mean? We're just some high school dropouts that love to drink and do drugs. You know what I mean? Yes. Is that what it stands for? I didn't know what the LE stand for, DJ. But yes, we're not Elon Musk. We're just some average guys that love to drink and do drugs. You know what I mean? And that's it. Have a little fun on the weekends. You know what I'm saying? That's us. And we like to get out there, get our hands dirty, and yeah, that's it. So let's go. Okay. So we have made it to the source side of our PLC. So now really quick, what is going to be our output on our PLC? I am not going to wire my motor directly to my PLC. That will be a no go. Never do that. Never wire your motor or your load directly to your PLC terminal. You're going to have big problems if this ever has big problems. That will smoke your entire system. If you're going to lose something, we talking some VFD. I assume you have PNP input output. Your input output will either be 2 outputs or 1 if you run through an ice cube. Oh, hold up. Hit a fuse or yes, 1000% or a VFD. Yes, you never have your PLC do the heavy lifting. Yes, you don't do that. So we're gonna wire this guy to a little ice cube. You know what I'm saying? So let's see how this goes. So I already have my ungrounded conductor from the ice cube relay right here. So where is this conductor gonna go? Where would I put this conductor? If I want to, do I wire it into my power? Where would it go? It's gonna go to my output, right? Okay. So let's go ahead and get it in to my output. And to be honest with you, I just want to use a short dog. Since my little jump is right here, I don't want to use all this wire because I might have to use this wire for something else. So let me use a shorty. A little short. Dang, come on, man. Where the heck is all my wires at? So let's go to the bag of tricks, right? And we'll just grab another little shorty. shorties up in here? No? 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 Here we go. We got a shorty. Boys. I found it. I found a little shorty. I just don't want to use a big old long one because I might need the long one for something else. So let's go ahead and get that guy up in there. Up in there. And I know a lot of you guys out there know how to do this already. I've been watching and listening to how many people come into this chat, and a lot of you guys are like some big brain energy. You know what I mean? Some real big brain energy. And I'm ready to learn from you. You know what I mean? So where you at? Where you at? Tell me where you're at so I could go and learn. That's what I want. I'm trying to step up my game using what you have to offer. 1,000%. 1,000%. And I'm not on no, I'm on some real, let me learn from you. You know what I mean? I'm on some real, let me learn from you. If I have anything to offer, I'm going to give it freely. And if you got something to offer, I'll take it. Hell yeah. Hey, I am not too proud. You know what I mean? I am not too proud. I'll take that. I will take that. And you could yell at me. You could yell at me. I'm not going to get mad. You know what I mean? But I'll learn. Oh, look it. We got another short dog. Ooh. Ooh. Okay. We're going to save this one. We're going to save that one. So now we got one wire wired into our output. Right? So now let's get... So we got the load side of our output wired. So your output is just a switch. So let's wire in the hot side of our output. And for that, I will use this red wire. Bam! 10, 12, 14, 16. Bam! There we go. There we go. So let's get this guy up in there. You know what I'm saying? There we go. Bam. Okay. Okay. Bam. Okay. Okay. So now we got this guy. And that guy is going to have to go to... Let me clean this up a little bit. That guy's going to have to go to this guy right here. So we will take this guy and we put it right up in here. Boy, yeah. Plenty of space. These little Wagos right here give you plenty of space. So now we got everything wired up. Okay. Sweet. Let me see what you guys talking about out there. What you guys talking about? Oh. No invites. Program rungs in PLC. I already programmed them, Keith. Is the output rated for 120 AC? It is. Is TG terminal 14 of Ice Cube is load of fan and common of fan to common. Yes. Yes. Can you fix a I hope so. You got a broken flashlight? All right. So let's see. Let's power that up. Right? And let's see if we get the... Okay. Okay, so we should be ready to power up. Why he not coming on now? Let's see, what do we do here? I undo him. Let me see. Oh! Why he not coming on, son? He should have came on. Let's see, so we got power. We got power. I think we're outputting. So let's get this guy in there. And let's go to the top side. We have voltage. Go to the bottom side. We have voltage. There he is. Oh, we got a loose connection. Huh? Look at that. What do you know, boys? What do you know? I was getting worried. I was like, damn. Did I just make a mistake on the live? No, we got a loose connection, fellas. So let's turn that off. And let's find it. Where the heck do we got the loose connection at, boys? Let me turn off the power. And it's somewhere on this wire right here. This wire right here. Is it in there or is it in here? Let me check. So we got there. We got a loose connection, boys. I'm telling you. Oh my God. That will drive you nuts. You know what I mean? So that one looks good. We got plenty of meat on that wire. So let's go and check that. My PLC wasn't coming on. And I'm like, what's going on? I should see an hourglass right away. A little screen illuminate. You know what I mean? So I think my loose connection is right here. Damn, son. That's how easy it happens. So I think my loose connection is right here. Damn, son. That's how easy it happens. That's how easy it happens. Right? Let me make sure that that's it. Because it could be... It could be there. I guess it could be here too. Let me check this one. Let me check this one. Let me give this wire a little bit more meat. I'm not trying to have none of that. None of that. Bam. I'm not trying to have none of that. I'm not trying to have none of that. Oh, okay. I hope we're good. If not, we're having problems somewhere else. So let me make sure everything is good. Where does that go? Okay. Why is that? Oh no, this is what happened. This is what happened. We had a loose connection on our neutral wire, it looks like. How the heck did that get out of there? We trim that. We put this back on. Alright. This is ballast wiring. This wiring is from Lighting Ballast. I like it because it's already coated with solder. All the wire inside is already coated with solder. It's really nice. You don't get no fraying. So now let's check it out, guys. I'm sorry about that. Sorry about that, fellas. I'm not trying to make you guys impatient out there. Boom, there it is. There it is. We got the hourglass. So we got the hourglass, right? And we are showing no outputs indicated. Yes, learning from home after work. 1000% user. We gonna be money printing. We're gonna be money printing, fellas. Brother, you HVAC controls or electrician? Electrician, Juwan. Yeah. I guess if you want to add a title, you know what I'm saying? If you want to add a title to it. So we got no outputs or inputs indicated yes. Indicated yet. Ugh. My words. You guys got to remember, I did not graduate high school and I am a product of the public school system. My words. You guys got to remember, I did not graduate high school and I am a product of the public school system. Public schools. That's me. Okay, so let's go ahead and shut it down. Bye out, right? Bye out. No power. No power. We're good. Just in case. Just so you guys just so you guys can sleep easy at night, I'm gonna go ahead and pull out the Widowmaker. And just to prove that the old Widowmaker works, let's go ahead and fire it up one more time. Just for me to feel better. I'm gonna go ahead and hit that. There it is, you hear that? Ah, that is a beautiful sound. That means you're not gonna get tagged that day, son. 1000%. 1000. Make sure the processor is in run mode. The processor is not in run mode right now. It is the program is in stop mode. Yellow ASA PLC. No, that is a IDEC PLC. I put a sticker on the screen. If you check out the sticker, let me see. There it is, moving around, and I'll leave them there. Yeah, that is a IDEC FL1D. It is the older version, but many people make and use that same little PLC box. You know what I'm saying? Hook it up with the laptop. I can't. I don't have the input wiring, and it doesn't even, you don't hook it up. It's not RJ45 or what do they call it? It's not ready for comms like that. It's an older model. It's basically a Eaton Easy 4. Yes, it's the same thing. It does take a card, but I don't have the card. You know what I mean? I don't have it. And this isn't what's that called? It's not network ready. Yeah, it does take a card, but I ain't got it. If I pop out where the card would be, right? So the card would be right here. Ah! So this is where the card would go, but mine has got nothing in there. It's just a little cover. You know what I mean? Not Allen Bradley. No, it's not an Allen Bradley. Who's your fuse supplier? Probably Granger or McMaster Carr is pretty much who we get it. Square pin connector, white in color. Yes. So okay. So I'm gonna put that back. Square pin connector. There it is. Okay, so we got that back. Hold up. I'm getting thirsty from all this talking. Hold on, guys. I got to feed my fish. That's either an IDEC Siemens logo. Yes, you already know. That's an old cable. I have one. It's a glorified FTDI. Yes, it's IDEC, boys. You're gonna hook up dual primary, single secondary transformer? No. I am going to hook up a dual input, single output function. Hold up, I gotta feed my fish, boys. All right. Good. I think I've now done everything I needed to remember for the day. Feed the fish, check. Take a shower, check. Brush your teeth, check. Hey, thank you, Keith. All right, so here we go. So we got that in. Okay, cool. So we have our ice cube relay wired. We have our source voltage breaker wired. We have our PLC powered up. So now let's get an input, right? So what are we gonna do for our first input? And I wanted my first input to be, drum roll please, nothing, huh? Okay. Oh, where's my selector switch? I want a maintained selector switch. Hold on, boys, hold on. Alright, sorry about that, guys. It's outside. Let me go grab it. So the first input is going to be a selector switch. An old crusty selector switch, right? Nothing fancy, boys. Nothing fancy. So what am I going to do to wire in the selector switch? What do I have to do? So if I wanted to use this PLC to run this fan motor, where would I wire the selector switch? On the output side, it's normally open. It's normally open. The green means normally open. I'm wasting precious time. Yes, I'm wasting a lot of time. So where would I wire in the selector switch? On the input side or the output side? That's the question. Let's see if somebody could hit that. Input side or output side? I'm sure a lot of you guys know it's a simple question. Input side or output side? Out. You're funny. You're funny, Ramiro. I like that though. I like that. I like that. It's not all that serious. It's very serious, and at the same time, it's not serious. You gotta treat it serious because there's a lot involved, but you also have to have fun doing it. You know what I mean? That's what it's all about, boys. All about having fun doing your craft. If you're having fun doing your craft and you're with the fellas at work and you guys are having a good time but still a level of being serious and motivation to get the job done, man, it doesn't even feel like work. It does not even feel like work. So here we go. We are going to wire. Where is my... Here we go. We're going to wire this guy on our input. On our input wire, right? Our input terminal number 1. Input terminal number 1. Bam! There it is. We'll go to my selector switch. Let me open up that a little bit more. You guys can see. I don't know if you guys can see. Let me try to show it to you guys. Oh, look at that view. Look at that camera, boys. Look at that camera. You see that little closey terminal in there? Look at that camera. Now we're at 24 volts. I mean, not 24 volts. Edmund, we are at 115. 115. That's a good question. That was literally what I was going to talk about next. But you beat me to it. You beat me to it. And where we at? We're at 120. This PLC needs a 120 volt input signal in order to trigger the reaction. So here we are. Look at that. Got it. Okay. Now that I put that into the terminal, I'm going to give the old-fashioned little tug test. Ah, nice. Tug test. Okay. Okay. So now that we got this looped in, let's go ahead and get another red wire, right? And tap him into my 120 volt side, right? Now we're getting somewhere. Now we are getting somewhere. There it is. Look at that, boys. Look at that, huh? Tuck those back. Look at how much wire. Look at how many connections there are just to get to where we are right now. It's crazy. This one going that way, this one going that way, this one coming in here, this one going out of there. It'll confuse you if you're new to the game. Very easy to get confused. As a matter of fact, it would be intimidating. Intimidating if you have not yet spent the time to understand that, hey, it's just basic wiring. You know what I mean? It's a lot of wires just to do something simple until you understand that it's just basic wiring. You know what I'm saying, boys? You know what I'm saying? Ivan, what's up? Mr. Blue. All right, so let's get that. Okay, so we have got our breaker. We have power to our PLC. We have our ice cube relay. We have our breaker wired. We have power to the PLC. We have power. Hold on, guys. Hold on, boys. Hold on. Oh, crap. All right. So, what's the signal for the input? The signal for the input is 115 volts. That's the signal for the input. Everything on this, on the input side, is 115 volts. Sorry, guys. Oh, whoa, 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 whoa. Sorry about that, fellas. Yeah, 115. So the hot 115, not the neutral. Yes. So that would be called syncing and sourcing, right, Edmund? Syncing and sourcing. So the hot, yes. So we have that going on, right? Let me flip that on. So right now we have power up to the breaker. Power in the breaker, not out. That's just carryover voltage from yes, we're good. So let's go ahead and flip that on. We have our selector switch off.
Okay, he ate them and he's trying to okay.
Boom. So far so good. Let me pull this out. Right? Let me close that up. Let me close that up. Oh, dude, those little Wagos, when they snap back and they hit your finger, they hurt. Okay, so right now, we are here. We have our screen, which shows our inputs and our outputs. So now let me show you guys what happens when I click the input. Boom, our output is outputting. You see that little black mark? There it is, it's off. Output is outputting. On, off, on, off. You know what I'm saying? All this to just turn a light on? Yes, and a fan motor. And this is the relay that is going to do the job. Let me get his hair out of his face. Get your hair out your face, boy. Get your hair out your face. There it is. Let me see, you guys can see it. See that? See the little thing turning in there? There it is. Okay. So now we've got our input wired and we've got our output to the ice cube relay, right? Booyah! We still need the other switch. Yes, we're going to get to that one, Edmund. That's going to be the big one. The whole point, Edmund, is that our other switch is not a switch. We got to hook up the power supply for our other switch because our other input our other input, is a capacitive sensor. This capacitive sensor is going to be our other input. Yes. So this is 1 or 2, not 1 and 2. Yes, OR. This is an OR circuit. This is a OR circuit. Yes. Not AND, right? So that would mean I would have to turn on input 1 and input 2. Kind of like the nuclear codes, you need the 2-keyed switch. You know what I mean? This is not the nuclear codes. This is just a tabletop setup. I like that though. It sounds like you know what time it is though. You know what I mean? I like that. I like that. I like that. So let's go ahead and power down. Bow. Bow. And what we will do right now is get this guy powered up. Let me give you guys some red meat and hopefully show you guys. So let me find what terminals we're going to be dealing with when it comes to this relay. Man, there's too much wire going on here. So let me use my continuity setting to find where we're at on that relay since, oh, here's the code right there. Okay. So let me see. What is my normally closed circuit? Right? So it looks like so let's see here. This is my common. So this is it. Because I cannot see that. Let me put this, because I can't see that. So it looks like my common is number 12. Number 12 is my common. And on this side it's number 9 is my common. Number 4 is my normally closed. And 8 is my normally open. On this side 1 is my normally closed. And 5 is my normally open. Okay. Yes, this approx sensor. So what do I want to wire to my common? I want to wire a hot conductor to my common. So we're going to use one of these blues for my common. You know what I'm saying? And I'm going to cut this down just a little bit. Let me see. Hold up, hold up, hold up, hold up, hold up, hold up, hold up. Sorry, guys. Trying to get squared away here. Let me strip this out. In typical electrician fashion, we're going to do the 10, 12, 14, 16. And now you don't see it no more. Where did it go? You know what I'm saying? You know what I'm saying?
Yeah.
No, that stays there. And we will wire that to that. Then we will wire. Let me cut that a little bit shorter. I definitely do not need all that wire. Turn that off. And we are going to go to this side. And then we will wire this guy. Closed, right? Ah, okay. And then we will get this guy, set him up right there. And then we're going to wire him to our normally open. Our normally open Okay. And then we're going to get this guy to a neutral. Right? Bam. Okay, let's do that. So what am I going to use? I guess I can use... I guess I can use this wire. And then I will use a double Wago, little double, and just get him and him wired together. So with that, right there, with just that, I should be able to close my selector switch and at this point power up that fan, right?
Oh my God!
Right? Let's see. Let's see if that's the case. Let's see if that is the case, boys. Okay. Turn this on. There it is. There it is. That's basic wiring. Okay. So now we have gotten the first fan, our first. We have gotten our first. All right, hold on. Let me I'm gonna get the sensor right now. I was just trying to get that one out the way first. You know what I mean? Yes. So now we have gotten an absolute basic function operational. We have wired a selector switch or an input. We have wired one input to one output. We have wired an I to a Q. Yes, sir. That is it. So that is one input to one output. It's similar to an Arduino. Yes. Yes. You guys are you guys obviously know this stuff already, so it might be boring to you, but hang in there. Because a lot of people do not know or understand this. You know what I mean? Absolutely. A lot of people do not. And we're getting there. I'm taking my time. I'm having fun. And I hope you guys are too. It's just, this is what it is. Step by step. Even at the pro level, wire a VFD. I will. Why is it so hard to understand for me? Houston, it's not. This is, okay, Houston, this is, thank you, Edmund. This is not your wall receptacle turning on a bathroom fan or a bathroom light type of wiring. You know what I mean? This is the next level, or even a level after that, type of wiring. But it's not hard. It's the same principles. All the principles are the absolute same. So when you learn the core functions of electricity and how to move electricity around, I want to take electricity from here and move it to here, you're going to understand it. You know what I mean? The only difference that we're doing today is we are using digital discrete logic. We are building a relay circuit to control an output. We are building, learn AC and DC fundamentals. Yes. These are fundamentals. The fundamentals of electricity. You can understand this, Houston. Yes, it's not next level. This isn't Tesla. This is this is like some backyard brawl. You know what I mean? Who's that? Iman? Yes. Once you understand that, start learning all the types of devices and their purpose. 1000%, Edmund. It's all about the devices and learning how to use each device and what it does to function. So now that we have got
Oh, man.
that wired up, right? How do you know what wires to use? You gotta know what wires are an input and what wires are an output. When you're dealing with devices, everything is very simple when you break it down. You can upload full video on YouTube. I'm doing meter controls right now as a 4th year. Yes. My teacher says, look at the tree, never forest. Yes. So it's all about inputs and outputs, Houston. As far as the sizes. Oh, okay. Right here, we aren't dealing with anything that is high current, so we don't need large wiring. Do you have videos on YouTube? Yes, I have videos on YouTube and TikTok. My YouTube channel is 6-figure fingers. 6-figure fingers. You see those bad boys? Look at those bad boys, huh? Huh? Look at those bad boys, huh? Eat it. Yeah, those fingers have been through a lot, boys. Those fingers have been through a lot. I'll tell you what, they've been smashed. These fingers have been absolutely brutalized, boys. Absolutely brutalized. This hand got burned right here. Oh, man. My hands have been through a lot, fellas. Oh, 6-figure fingers on YouTube. The sausage, yes, I got the sausage fingers, boy. You know what I'm saying? Hey, but they still work. That's all I need. They still work to do what I gotta do. And I tell you what. Here's the deal. Hold up. Here's the deal. You could have fingers like this, and as soon as you learn this craft, you're only using the tips of your fingers. You're not even using, you know what I mean? Things get easier as you learn more. Yes, 1000%. So, as soon as you guys start to learn more, you start to earn more money. You start printing money with everything you do. So let's get back to wiring. I can learn as a J-man. It isn't too late. Oh, it's never too late. It is never too late. Hey, thank you, Houston. I appreciate you watching those. Yes. So I can't find you on YouTube. I don't even know where my other phone is, boys. 6-figure fingers or Rick Chavez. Rick Chavez. Hey, buddy, you know where my other phone is at? Oh, there it is. Oh, yeah, okay. Here we go. You don't know. Come on, buddy, help me out a little bit. All right, so here we go. So we got the other phone. We are here. YouTube. Right? Hold up. Let me turn off this light. Hold on.
Oh, it's so hot.
There's my channel on YouTube. Rick Chavez. That's my channel. My videos. And then I'll go to my videos. And you guys can see all my videos right there on YouTube. And my first video, my absolute first video, was not a banger. Fixing a hydraulic cylinder. I'm in California. This is my first video.
Good morning, ladies and gentlemen.
Ladies and gentlemen.
That gives you a bird's eye view into industrial repairs and installation.
Yes. That's my absolute first video, boys. Yeah. You know what I'm saying? Good morning, ladies and gentlemen. No, I don't. Yeah. So, it's funny. It's funny watching your first video that you ever put out. You're like, man, looking stupid as what? It's crazy. Yeah, it sounds social, right? SoCal? All right. So, now it's time to get our sensor. Now it's time to get the sensor wired in, right? But in order to get this sensor wired in, we need to hook up a 24-volt circuit. No, I'm in Orange County. So we need to hook up a 24-volt power supply. So that's where this guy comes in. This guy right here, boys. 24-volt power supply. And I'm going to put him over here on the other output of my inverter. Let me get this guy wired in, right? Bam. So we got the breaker off. Output. So now we're going to have to get, boom. We're at 24.3 volts outputting on the power supply. So now let's get this guy wired in. So we have the manual for this sensor, because I would hope that you guys do not wire it in blindly, and that you use the literature to wire them in. That way you don't mess it up. Since sensors are relatively expensive, and if you're using it for your home lab, you want to keep your stuff more than you want to lose it. You know what I mean? At least I do, because nobody's paying for this. I'm paying for all of this out of my pocket. My pocket, boys. You know what I'm saying? But it's okay. I am not crying. I am just saying I have to do my best to keep my stuff, because nobody's going to replace it. I have to replace it. You know what I mean? So here is the logic. This is the logic for that sensor. DC sensor. Yes. So there it is. That is the logic for that sensor. So this is showing that. What does that mean right there, though? What the heck? What does that mean? What does that mean? What if I wire this sensor in? What state is it going to be in right out the gate? You know what I mean? That's crazy. Normally closed. Absolutely. Absolutely. That means this sensor is outside of your typical normally open state or status. Most things are normally open in my experience. You know what I mean? You guys may work somewhere else where things are normally closed out of the box, but this sensor is normally closed out of the box. Weird. A little bit different. And this sensor has a positive, and this sensor has a negative. So that tells me, just that right there, tells me that the sensor is a DC sensor. Edmund, okay, you're asking me if it's PNP or NPN. You should be able to look at this, and I'm going to show you exactly what it is and how to tell by just looking at this drawing right here. This tells you that it is a PNP or an NPN. And how do I know, and how do you tell if it is PNP or NPN? And it's very easy. When I explain it to you, it is very easy. Positive, negative, positive, or negative, positive, negative? Yes, 1000%. So, what would you guys say that this sensor is? What would you guys say that this sensor is just by looking at the drawing? Negative out. Yes, 1000%. So if it is a negative out, NPN, you got it. You got it, Houston. This is an NPN. Why? Because it is a negative out going to your load, and your load, other side of the load, is a positive. So this is a negative with a positive, and for the sensor, you're running off of this negative. So, negative, positive, negative. So you have negative, positive, negative, NPN. And that's just kind of an easy way to tell right there. You know what I mean? That's how you do it right there. So yes, this is an NPN. Now, I can show you all the stats for this guy, and it will tell you. NPN, normally closed. There it is. There is your sensor right there. And it tells you all of the stats. But it also tells you some other information right here. It will tell you that you have an LED indicator on the back, and then you have a potentiometer right there. So it's going to show you that it has a potentiometer. So you can adjust your sensing range. I think it's not optical. I think it's proximity. Proximity. So yeah, it is definitely a proximity sensor. But what is the sensing range? Let's check that out. Sensing range, right? In millimeters. I love pot. Yeah, I know. A lot of you guys do love the pot. 15 millimeters of a sensing range. So that's a little bit better than most. And then you guys can see all the stats for this guy. Yeah. Yeah. Yeah, that's funny. Tell me more about about the pot, right? Well, I'll tell you what. Today's pot isn't green. It's orange. Have you ever had some orange stuff? Have a good night, man. Have you ever had some orange? Have you ever had some orange pot? Orange pot right there. Yeah, boy. Okay. So we gonna get this boy wired up off of the 24-volt source. Just the hairs, right? Yeah. Hey, I know, man. Hey, when I used to do it, can I please send you a picture of 2 motor starters and you explain? Yeah, you can send them over. Please. I took them today. Yeah, send them over, son. I got you. Yeah, send them to my direct message. And yeah, when I was doing that, when I was on the pot, right? On the pot potentiometer, the sensor will operate anything you hook it up to, any output. We didn't have good stuff, you know what I mean? Back in my days, we had dirt and cess. Straight dirt and cess. Yeah, the fan. Today it's a fan. Yeah, it wasn't no good. Nowadays, I'm kind of like, man, I almost makes me want to start again. There's a lot of good stuff out there. All right, so let's get this guy plugged in, boys. So here we go. So let's get, first of all, let's identify our positive wire. Who and what color is our positive wire? That's what I need to know. That's what I need to know. So right now, I need to wire in my DC, which takes a positive and a negative. So I need to know, who is my positive wire? Brown wire, BN, positive wire. Okay. So I need to get my brown wire to the positive side of my power supply. Let's do it. So let's take my brown of my power supply. Let's do it. So let's take my brown wire, right? We're going to take the brown wire, snap that bad boy shut, and not have it snap on our finger. And then, yeah, I could use this black wire. I'll use this black wire. You know what? Let me use a shorter wire, boys. I got some shorter wire in here. Yes. I don't want to use all my long wire. Okay. Since this is only going to be right here, so now I got to find the positive side and negative side of my power supply. So let's go ahead and use the meter to do that. I'm going to use the meter to double check. Come on. Crazy wire harness mess. And this is why terminal blocks and DIN rail is so helpful, because you could really clean up a panel when it's all crazy and messy. So let's go ahead and find which one of these is my positive and my negative. I'm gonna set my meter to DC, and then I'm gonna turn on. I'll leave that off. Turn on my inverter, okay? And then we will go to our terminals. Booyah. That is wrong. So I want to put, in order to tell we have a negative sign in front of our 24 volts. We have voltage, but it is the wrong orientation or the wrong polarity, right? So let's switch this. We have our positive to that. We have our negative to that. So now we no longer have that negative side. So that tells me that my positive is on this side. So let's go ahead and do that. Let's go ahead and do that. All right. Got that. Okay. Thumbs up on that. So now let's use another wire, and we're going to get the other wire hooked up to the negative side, right? Okay. Okay. So now, before I do anything, I'm going to double check. I'm going to make sure that I know exactly which wire on my sensor is my negative, right? And we're looking at the drawing, and it shows that my negative wire is my blue. BU for blue. All right, thank you for sending those pictures. Okay, BU for blue. So that means I'll go to my sensor, and I'm going to find my blue wire. I'll grab a little Wago, and we're going to wire that bad boy in. Let's go. Got it. Wago. Okay. Got it. So that means that when I turn this button, we should have a sensor that is powered up. And we do. We have a sensor that is powered up. See that? It's sensing my bones, my bone density. Yes, sir. El Groovy. Ah, all right. Okay, so we got power to the sensor. So now let's get the sensor power to the fan. How do we do that? I'll tell you what can we use to get that sensor power to that fan? Since the sensor is 24 volts and our fan is 120 volts. Like, how do we do this? You know what I mean? How do you get that to that? Like, what's going on here? That is where you're going to use one of these bad boys. That is where you're going to use one of these bad boys. I'm going to use one of these little guys because this is a supply voltage of 24 volts. And it's got a control voltage. So we got, what can we output on this bad boy? On this guy, we can output, let's see here, what do we got? Up to 250 volt, 6 amps. So we're good because we're going to be using 120 volts, but our coil is 24 volts. So I think we're good. You know what I mean? 250 volt AC. Yes. See the little sine wave? It has a little sine wave right there. Yeah, 250 volt AC. Got it. So let's go ahead and tap this guy right there on our DIN rail, right? Bam. Okay. Okay. So if our sensor is outputting a negative signal, that means we would have to wire our relay with the positive signal, and then we'll have the sensor controlling the negative signal. There it is. Okay. So here we go. Let's get that all wired in, right? And guess what? I brought just the wire for this too. Look at what I happen to have. 24 volt wire colors. 24 volt wire colors. Oh, look it. Aren't they a beauty? Aren't they a beauty? Doesn't it make everything better when everything is colored with the coordinating wire color? So that if you're used to working in panels, everything just looks so much nicer when it's coordinated colors. I don't know about you guys, but for me, that really makes it happen. You know what I mean? All right. So we could do that. We'll use these later. Let's use what I got. Let's use what I got first. So we got a blue. We got a blue. Let's use a blue. Let me strip this. Right? Bam. Okay. So let's find our A1 and our A2, which I'm guessing. Let me make sure this is not. So where is the positive and where is the negative? Let's see here. Does it tell us? Does it tell us? Yes. Yes, we're going to have the sensor operate the fan. Yeah, we're going deep. Yeah, absolutely. A1 and A2, protection and indication circuit. So it doesn't tell us that A1 or A2 is positive or negative, and neither does this one. So it looks like we're safe to wire it either way. A1 is positive, A2 is negative. Okay, I got you. I got you, Martin. Okay. All right. So this is A1. So let's put our wire to A1. Up. Let's flip that bad boy, huh? So these aren't screw terminals. These are like push locks.
That's just a desire.
Oh no.
I see this one. Right here. I don't know how many people.
Hold up, son. Let me find out
Oh.
which one is my terminal and which one is my push lock. Damn. I'll be pissed. Okay, which one is it? Flat that way, right? Damn, son. Where's it at?
Okay.
Damn, I am not trying to break this bad boy. But is that the...
Office.
She. Let me see. Hold up. Get this bad boy in there. My screwdriver's beat up. My tip is not the greatest. Let me see. A1. Put our positive in our A1. Okay. Nope, that is not doing it. Is it this guy? No, it has to be this one. But it is not doing it. Get in there. Okay, if we're going to have to scrap this, I'm just going to get another... yeah, because you know what? I don't like these. I'm already giving up. I don't like those. So we're going to go to... and this might be why people go to the Allen Bradley. You know what I mean? Because they're just a little bit nicer. There you go. That's making more sense. Yeah, those were... yeah, there we go. That makes more sense. So we move into the Allen Bradley, boys, because we just weren't liking those ones. There we go. Bam. Look at that. Huh? Huh? Man, that was crazy hard time right there. Crazy hard time. At first I thought you were wearing a PLC. I guess it's not that far off. Laugh out loud. Yeah. Using 13. Yeah. All right, boys. All right, so we got that. So here we go. So that is it. A1. Okay. And then this will go with our positive. So let me put a 3 block on our positive right here. Okay. And then we will put this in with our positive. Bam. Okay. I'm going to move this along now, fellas. Now we need... this one is going to be off of our switch leg, or it's called your control output. Switch leg or control output. Here we go. Okay. There we go. Boom. Okay. Cool. So we got that so far, right? Bam. So we have power to our relay. we have power to our relay. Since this sensor is normally closed, you're going to see my relay operational, out of the state function. Off and on, off and on. Since that sensor is normally closed. Yes, sir. Okay, so now we got that. So now let's make this operational. We're going to need a power circuit. Here we go. Let's take all these wires out. Bam! Okay, that is that. So now we got. Ooh, we're gonna need to get that one out. Let's get this one out. We need more wire. Okay, so now we got 2 more wires. Boom. So now let's get the wiring, boys. Okay, so we will have a normally closed here's the common. Okay. And we're going to hook up that common from our sensor to our power circuit. Let's get that into our power circuit. Bam! Got that. Okay. That will be the common. And then we will hook our other one up with our fan. So let's go ahead and get this into a triple. Got that. Got that. Got that. Let's turn this power off. Turn that off. Oh no, that is not the right one. Okay. That is our neutral. Sorry about that, guys. Let's get this guy. Oh, so he's there. Okay. So we will make him operate in order to get the fan. We're going to have to take him out of there and add a wire. So we will add a wire into here, right? Add one wire into there. We're trying to get to the finish line, boys. We are trying to get to the finish line. Hold on, if I could ever get this terminal tight. And we got it. So now we will put him into there. Put him into there. And then we will put one more wire from our normally closed bam, into here. And I think that should do some basic functions. There it is.
There we go.
So where is my... Here we go. So we're going to turn on our first input. And let me make sure. So we are operating off of the switch. See the fan? Operating off of the switch. Fan is operating off of the switch. And the fan is also operating off of my selector switch. You guys see that? You guys see that? Gotta go, brother. Hey, yeah, catch. Hey, I'll see you, Martin. Yep, yes, sir. So that is a fan operating, or a output operating off of a dual input. You guys see that? Look at how crazy that looks though. You know what I'm saying? A lot of you guys, it's late. Been on here for what, 2 hours now? Just to get a simple input-output function, because I'm kind of low-key explaining it. And I hope you guys can see. If you guys got any questions, go ahead and slam them in that chat. Slam them in the chat, boys. DJ, you still here? All right. Hey, you see that though? You see that though? We got our output, which is our fan, operating on the momentary or maintained selector switch. Got that? But let's say we want to kick our fan out of what would be called manual. In manual mode, there's a setting called manual and auto. Have you guys ever heard of the phrase manual and auto? This is, we in here, yes. This is called a manual and auto setup. Manual and auto. But in order to do a manual auto, I would need another position selector switch. So I could go to manual and auto. Now, if I was to kick this fan into manual mode, I would turn it on right here, and the selector switch that would have 3 position. Boom, manual. Turn on my selector switch. And if I wanted to kick my fan into automatic mode, automatic means it operates whenever X thing happens, I would turn this off and set it to auto. And once I set my selector switch into auto, please don't forget to accept my pictures. Yeah, I got you. Yes, I got you. Yeah, I'll accept it as soon as I get off this live. So that is a manual and auto function. Now check it out. We are off, or we're in auto. Boom. Look at that. There it is. There it is. That is it. So that would be operating in an automatic function in your machinery. And this is a very, very common application out in the field. Let me get this on a napkin so I don't kill the kitchen table. Okay. There it is, boys. That is it. That is how the magic works. Noah, thank you. Please don't forget. Yeah, I got you, Noah. That is how the magic works. Look at that. You know what I'm saying? And you see right here, you guys would see if I could pick up the PLC, but it's a crazy mess full of wire. Ivan, thank you. Yes. But yes, that is your manual auto function. Whenever you are dealing with machinery, whenever you are dealing with controls, this is a common wiring method that you guys are going to run into. A manual auto function. Manual, off, and auto. Very important. Maybe I'll make a video about this, but you guys seen it took me 1000%. I designed and wired, designed and implemented for you guys right in front of you. You know what I mean? On a live. So that you guys can see that it's actually very easy. It's actually very easy. 1000%. 1000%, boys. Hand off auto, hand off auto. Yes, that is it. So are you using a low voltage momentary switch? Right now, I'm not using my switch. So right now I'm operating off of my sensor. But look what happens when I turn off my sensor. I pull my sensor off of, I'm going to pull my sensor off what it's sensing. Right now it's sensing this wire. My fan's going to go off, right? Put my sensor to the side, and now I turn on my switch. Operational. But I could hook up my sensor, and now I could turn off my switch, and we don't miss a beat on the fan. You know what I'm saying? If we use a foot pedal, how does wattage affect being able to be controlled or not? If you use a foot pedal, it is the same as a switch. So if you want to wire this into a foot pedal, see this? This can be a foot pedal, a limit switch, a selector switch, a push button switch, all manner of stuff, a toggle switch. They're all the same. A foot pedal is just a switch. You know what I mean? 1000%. A foot pedal is just a switch. No different. So is a sensor. A sensor that is running this right now is just a switch. See that? It's just a switch. Just a switch. But it is a controlled output switch. So do you have the motor on a starter? No. The motor is on a relay. Right now the motor is operating off of a relay right here. If I was to pull this relay, I guess it's, because it's off the switch right now. It's running on this relay right now. So I got two relays. Duh. One relay is wired to my switch, right? One relay is wired to my switch, and my switch is wired on 120 volts. And I got another relay right here. See this little one right here? That is wired to my sensor, and that is 24 volts. 24 volts. Because I'm mixing, hold on. Form C contact relay. Who's that? I use foot pedals with potentiometers, and the wattage doesn't line up for some reason on some drives. You use foot pedals with potentiometers? You might need some more devices in order to get that right. Because a potentiometer is not a discrete or normally open, normally closed device. A potentiometer operates on resistance. It is a resistance band that you're wiping across. SFA controller. Hold on. What did that say? Hold on. SBA controller. That is just a typical PLC. I see you are. Yes, that is a typical PLC. Nothing more, nothing less. This is a what would you call it? You see the sticker on the screen? This is a IDEC FL1D PLC and discrete input output or analog. It has both. Right now we are hooked up to discrete input output, no analog. But we're going to get to analog. It's just too much to do today. But yes, we're gonna get there. And Hey, thank you guys for 77,000 likes. Oh, come on, boys. Come on, boys. Shout out to the chat, my guy. Shout out to DJ. DJ, you a savage, my boy. You a savage. This is my kind of content. Hey, thank you. I appreciate it. You a savage, DJ. Hey, DJ's my guy tonight. Tonight, you're my hitter, dog. You my hitter, DJ. Tonight, you my hitter, my guy. Straight up, dog. I'd like to thank everybody. Hold on, let me give a shout out. Let me give a shout out. Hold up. Let me give a shout out. I gotta do the shout out, boys. I gotta do the shout out. I want to give a shout out to everybody that made this possible. Everybody out there that made this possible. I want to give a shout out to DJ, my guy. Give a shout out to my moms. You know what I mean? And I want to give a shout out to my parole officer. Shout out to the PO for letting me out of jail. Straight up. The PO let me out. And I told him, I promise you, I'm gonna do better. I'm gonna do better. They let me out and I never looked back. You know what I mean? Shout out to you, DJ. Shout out to you, my guy. Yeah. We out here. You know what I mean? So you are energizing the relay on 24 volt and the contact on relay have, yes, you are reading it. Yes, I am energizing this relay. I don't want to pick it up, boys, because it's got a lot going on here. I am energizing. Let me see. I don't want to get, let me turn that off. Booyah! I don't want to get swept up here. Let me get this a little bit closer. I am energizing this relay right here, boys, on 24 volts. 24 volts. But the output right here is 120 volts. So my coil on this relay, my coil is 24 volts. And my output, my discrete output, my normally closed is 124 volts. My switch leg is 124 volts. Now I'm also operating this relay right here on 120 volts. And my output, my switch leg, my control leg is 120 volts also. But this relay right here is being controlled from the PLC. This relay right here is being controlled from the sensor. See that? See the sensor? Yes. So let's do a solid state switching MOSFET. Yes, we can do all manner of wiring up in this kitchen. We can do all manner of wiring up in this kitchen. That's what kitchens were made for. Wiring control circuits. Shout out to the chat. Shout out to you guys for 78,000 likes. Savage. We've been here for a minute. I've been talking a lot. And there's been a lot going on. But this is a solid learning session if you guys don't know about this stuff. You know what I mean? 1000%. This will get you guys to make money. Money. Let's turn on the money switch. Turn on the money switch, boys. Let's turn on the money switch. How do I make money using these simple controls? I went from making $12 an hour to 80K learning controls. We are money printing machines, boys. Absolutely. Who's that? BG? Is that your name, BG? Yes, 1000%. We have the ability to print money through wires. Printing money through wires, right? That sounds easy. I'm Of course, I'm dumbing it down. Controls always in high demand. Absolutely, BG. I'm gonna call you. I think it's BG. My eyes ain't so good. So, my man, not kidding. It can be a lucrative business. Yes. Learn SIL1 and write your ticket. Yes, 1000%. Now, here's the deal. Here's the deal. You can't walk up to. Yes, thank you for the follow. 3 little pugs. Shout out my guy. Thank you for the follow. This is what it is. This is what it is. This right here will allow you the ability to print money on and off of work. What do you mean, Big Rick? How am I going to use this to print money off of work? I'm telling you, once you have the fundamentals of electricity in your brain and you know all the principles of normally open, normally closed, input and output, discrete, analog, you're unstoppable. You will be absolutely unstoppable. If you think about just taking motors alone, just motors, right? This little fan motor right here, spinning and smacking my hand, right? This little fan motor right here. You think about motors. You want to sit down here, everybody? You sit down? Okay, yeah, go ahead. Okay, if you think about motors, motors are everywhere. Everywhere. You will always have work. That's one. You will always have work. Depending on the complexity of your install, depends on what you're going to earn on each job. If you're a contractor, you're writing your own tickets. You are absolutely writing your own ticket on how much you want to make that year. If you can find the work, whatever your method is to find work, right? And I'm sure it's not Angie's List. You know what I mean? I'm sure it's not Angie's List. You know what I mean? But I'm not going to knock Angie's List, and I'm not going to knock Craigslist or Facebook Marketplace, because they're all good means to find work and to write your own ticket on simple, easy installs. You guys have this under your belt, you can print your own money. Money printing machines is what we are, boys. Is what we are, boys. Simple, little hand tools, 1000% will get you there. 80,000 likes. Yeah, shout out to you guys. Shout out to the chat, boys. This is it, fellas. You guys can print your own money. Let's do a single phase 240 volt to 3-phase using a capacitor and run starter. I am working on this project. Yeah, I like that. But I don't want to hook up. Look at this. We're running all of this off of a simple little inverter. You see that? That is my power source. I'll help you, buddy. That is my power source for the whole operation, boys. There you go. You want milk? Okay. Let me get it for you, buddy. Ah! Okay. Ah. I got you. Okay, ready? Okay, take that and go get a spoon. Go get a spoon, buddy. All right, yes, so that is the power source. A single inverter in order to power up all of this control wiring. I am running a motor, which is the load. I am running the load off of both 24 and 120 volts. I am running a PLC off of 120 volts right now. We're running two relays. One relay off of 120 volt coil, and one relay off of a 24 volt coil. Yes, sir. That was tonight's dinner. I like use AC DC box. Work with those when I got instrument degree. Shout out to you. Is that AI? Yeah. Hey, instrument degree. That's a solid, my guy. Solid. 120 volt inverter, 24 volt power supply, and you can have all this madness right here on your kitchen table too. Straight up. Straight up. You know what I'm saying, boys? You know what I'm saying? Yes, sir. Yes, sir. We got 33, from what I can see right now, people in the chat tonight. Tonight we were wiring in the IDEC FL1 PLC, and we made it happen. 34, 36, it goes up, it goes down. We made it happen tonight, boys. We set out at the beginning of this live. We set out at the beginning of this live with nothing running. Absolutely nothing running. I had a PLC in my hand with no wires to it. And now we are running a full scale input output controlled load with 24 volts and 120 volt voltage sources. We're controlling in two different control methods. Two different control methods are controlling one load. If you guys can learn this wiring, this method, my hat's off to you. My hat is off to you. And if you guys don't know how to wire this yet, it's okay. Do not worry about that, because Big Rick got you. Big Rick got you, boys. Big Rick got you. I got you. I'm going to take my time and I'm going to teach you guys step by step. 1000%. I'm going to show you. But hold on. I'm not just going to show you step by step. I'm also going to show you in two different languages. English and Spanish, boys. We teaching in two languages, fellas. I don't think you guys understand that. We teaching in two languages, boys. You know what I mean? I'm showing you guys multicultural training. Straight up. Multicultural training up in the house. Straight up. I had to wire a breaker and run a 3-phase motor from it. Yes, 1000%. Mexico uses 120 and 60 hertz. Yes, 1000%. I am not discriminating around here, boys. You know what I'm saying? I am not. I'm telling you, we are not discriminating around here, boys. We teaching every language we could get our hands on. We teaching every device we can get our hands on. If it's out there and I could grab it, I'm going to teach it. Straight up. I'm going to teach it. You know what I'm saying? Is that a VFD system? No. This is not a VFD system. This is a, hold up. This is a PLC system. That is a PLC, a modular PLC. It was confusing to me at first, but after learning how to read it, it became a lot more simpler. Yes, everything is confusing at first, and then it becomes a lot more simpler. All you have to do is have patience and stamina. What is the capacitive resistance? Oh, now you're talking some math. Now you're talking some math stuff. That has to be calculated, Jimmy. That, I don't think we're going to do that tonight. The capacitive resistance, that is a loaded question. That's rough. I tell you what, when I was going through school and we started to do all the, it's probably not good. The power quality for this is probably not good. When I was going through school and we were doing all the math and the power quality and capacitance, inductance, oh my God, that's a rough ticket. You know what I mean? Electrical math is complicated, but it can be done. If I can do it, you guys can do it. 1000%. 1000%. Let me move this, and we will put the meter behind this. So that you guys can see the PLC operating, boys. You know what I mean? There it is. That's for engineering. Yeah, you know what I mean? We don't really do that. We ain't got to do that. But it's good to know it. There's no VFD, I don't think. No. This is not a VFD. Math versus reality, right? Yeah. No. Jimmy, you got it 1000%. There it is out there. I'm just saying right now, yeah, I just don't need that. If I was designing a system, like, I guess you got me right there, because yes, we designed this system tonight. We 1000% designed this system tonight. The only thing we did not include in tonight's design, because things got a little bit long, was an indicator light. And that's what I told you guys I was gonna do, and I didn't do it. Big Rick lied, and I feel super bad about it. I feel so bad about it. You know what I mean? 1000%. Yes, sir, fellas. We hit 85,000 likes, boys. 85,000 likes. I appreciate you guys. I do what I can for you guys. For those of you who are hungry to learn, that's the target audience. And still going, yes. Antonio, gracias. Thank you. I do what I can to teach you guys, for those of you who don't know. And for those of you who do not speak English, I'm shooting it out there for you too. You know what I mean? And if I knew Vietnamese, I would be teaching the Vietnamese as well. But yes, we are out here doing the work, putting in the work to make ourselves better, to produce a profit, to print money, to take care of our families, to improve our daily lives and our lifestyle. 1000%. That's why we do it. That's why we do it. You know what I mean? 1000%, boys. I had trouble with the PLC class, like all the rungs we had to create for like a stop light. Yes, you are going to have trouble. That is good. That is okay. Having trouble with this is okay. That is not something that is out of the ordinary. That doesn't make you special. Having trouble and not understanding programming PLCs does not make you special. Yes. So don't think you're special, AI. Don't think you're special just because you didn't get it. Oh, I'm the only one in the class and I didn't understand it. I'm special. No, you're not. A lot of people don't understand it. You know what I mean? So, we are operating here off of two different input sources. Let me turn off this, and then we will operate on this capacitive sensor as a controlled input to turn on a load, because I have this PLC programmed. I programmed the PLC for a dual input to control one output. A dual input controlling a single output. It's RS Logic 500 will help you with programming. Yes. RS 500 logic. The programming logic can get complicated, but you just don't overcomplicate it. Right now we are running off of that little capacitive sensor, and it is looking lovely. We've had this fan running for a minute. We're about to be out of batteries. We just running off of 2 Milwaukees right there, boys. 2 Milwaukees. Razor Ray. Every reaction needs a reaction. Yes. Every action needs a reaction. Yes. So we put voltage in, goes through a coil, and we produce work out. What kind of system run off these? Oh my God, brother. That is a good question. This is a classic old school black and white automatic manual operating system right here. We have an automatic and manual. One note away goes. Yeah. This is an automatic and manual operating system. We would use our sensor to operate the automatic function, and then we would use our selector switch to operate our manual function. So in the event that you had to troubleshoot getting a call or getting a job where they say, hey, my motor is not working. The motor is not working. I don't know what's going on with it. Can you help me? When somebody says, can you help me? That only spells money. You know what I mean? Unless it's a family member. When somebody says, can you help me? That equals money. You know what I mean? You can also use stop start with holding contact if you don't have a PLC. It will do the same job. Yes, 1000%. I can use latching. It's called latching. I can use your latching and just use a straight relay with the latch function. But in our last live, a lot of people in the chat were saying they wanted some PLC stuff. So of course, Big Rick said, hold up. So of course, I answered the call. What you guys wanted. This is what you guys wanted. Those guys aren't in the chat tonight, but this is what they wanted. And I'm giving it. I'm delivering. I'm producing results. I am producing results. And that's what employers want. They want to hire a guy that can produce results. When you get the call and they say, hey, that motor's not working, it's supposed to work when I do this and when I do this and when I do this, the motor's supposed to come on. And I did this and I did this and I did this and the motor didn't come on. I don't know what happened. You say, hey, don't even trip. Let me look at it. Let me go get my tools and we'll figure this out. You know what I mean? That equals money. You get the motor working. You produced a result from using everything you've learned up until that point that you got that call. So it's in your best interest to learn digital logic, physical logic, supply power, calculations, NEC, devices just in general, wiring methods. It's in your interest to learn so many different things. It's in your interest to learn what are the popular things that are out there that people are using. What are the new devices that are coming out? But if I was you guys and you're getting started, I would learn to wire all my old and basic devices like just an old school selector switch. You want to learn that all out the gate as your fundamentals. And this is just industrial. This isn't even stepping out into the residential or commercial field. You know what I mean? There's a lot of money out there that could be made. And by knowing these devices, you guys can print all that money. Straight up. What's up? You know what I mean? All right, fellas. I want to thank you guys for stopping by and for hanging out. I appreciate it. And we will continue this party hopefully sometime soon during the week. But yes, we're going to shut it down. And I will see you guys on the next one. DJ, hey, shout out to you, DJ. I appreciate it. Shout out to you, my guy. And we'll see you guys on the next one. Be safe. Take care of your families. Do your best every day. And stay safe out there. I'll see you guys.